Hello everyone, I'm Miles. Today, we're going to truly understand the nominal annual interest rate, also known as the annual percentage rate, APR, and the annual percentage yield, APY, because they form the underlying logic for corporate finance valuation and pricing. APR and APY are hidden within bond yields, loan pricing, and the real growth of discounted capital in private credit derivatives. How do they actually work? Today, we'll learn through problem solving, so in the future, you'll be able to instantly and intuitively convert between APR and APY. Let's assume today you borrow $100,000 at an APR of 6% for a term of 5 years. Part 1. Simple interest, no compounding. Simple interest. If the interest is not reinvested, APR equals APY. Both are 6%. And the annual interest is $100,000 times 6%, which equals $6,000. Without compounding, the APR is the actual cost. This is the baseline. Part 2. Compounding interest. Why does this change the reality? Now, the APR is still 6%, but compounding means the interest starts to contribute to growth. The most important formula: if M is the number of compounding periods per year, then 1 plus the actual annual yield, APY, equals 1 plus the nominal annual rate, APR, divided by M, all raised to the power of M. The key point to understand is that APY assumes the interest will be reinvested, meaning the money keeps rolling over. This isn't about accounting, it's about how capital actually works. The more frequently interest is compounded, the higher the APY becomes. The APR stays the same, but the cost of borrowing keeps rising. So if interest is compounded once a year, M equals 1, and APY equals APR, which is 6%. If interest is compounded quarterly, M equals 4, and APY is calculated as 1 plus 0.06 divided by 4 raised to the 4th power minus 1. That means APY is 6.136%. If interest is compounded monthly, M equals 12, and APY is 1 plus 0.06 divided by 12 raised to the 12th power minus 1. That means APY is 6.168%. If interest is compounded daily, M equals 365, and APY is 1 plus 0.065 divided by 365 raised to the 365th power minus 1. That means APY is 6.183%. If interest is compounded every hour, M equals 24 times 365, which is 8,760. APY is 1 plus 0.06 divided by 8,760 raised to the 8,760th power minus 1. That means APY is 6.184%. In the third part, when time becomes continuous and the compounding frequency approaches infinity, calculus tells us that the mathematical limit is APY equals e to the power of APR minus 1, where e equals 2.7183, the natural base. So the actual annual percentage yield, APY, equals e to the power of 0.06 minus 1, which is 6.184%. Continuous compounding is not just a theoretical assumption, but rather the way the market prices things when there are no time gaps. That's why discount factors, forward rates, and option models all rely on exponential functions. Part 4. Reverse engineering. Can you work backwards from APY to APR? True understanding is shown by whether you can reverse the process. If someone says the annual yield, APY, with continuous compounding is 6%, what is the nominal annual interest rate, APR? The nominal annual interest rate, APR, equals the natural logarithm of 1 plus the actual annual yield, APY. So ln 1.06 equals 5.827%, which is the APR. This number determines how loans are priced and how yields are quoted. Finally, the nominal annual interest rate, APR, is the language of company contracts, while the actual annual yield, APY, is the language of capital. Compounding's essence is reinvestment, and continuous compounding means reinvestment frequency becomes continuous.